Today our topic is linked list. Before learning this video, please learn our previous videos on linked list of this series. Then this video will be more clear for you. We already learned in our previous video there are three types of linked list: singly linked list, circular linked list and doubly linked list. We already learned many operations on singly linked list and circular linked list. Today we will learn operations on doubly linked list. In our previous video, we already learned what is doubly linked list. Doubly linked list is a type of linked list in which each node, apart from storing its data, has two links. The first link points to the previous node in the list and the second link points to the next node in the list. The left field of the first node contains null and the right field of the last node contains null. Then it is linear doubly linked list and the external pointer contains the address of the first node. These two links helps us to traverse the list in both backward and forward direction. There are many operations on linear doubly linked list we already learned. Today we will learn more operations on linear doubly linked list. So our first operation is add a new node after a specified location of linear doubly linked list. See the discussion first. Add a new node after a specified location of linear doubly linked list means user gives the location and I have to add this new node after that location. Say the location is 2. So after second location I have to add our new node. So here function name is add after. Here also I am passing the address of external pointer, that is this 600, and the location after which you want to add your new node. Say here log value is 2 and int num means the node which you want to insert, that node info is num. So if it is our new node and I want to insert this new node, this node info is num. Say num is 55. So here it is 55. Struct node star p star q means p can hold address of any node, q also can hold address of any node. I give p equal to star ext means p holds the address of the first node, star ext means 1000, so p is 1000. So p holds the address of the first node. This is p. First I have to create this node using malloc. So malloc allocate at the time of run struct node size memory chunk and it returns the initial address of this memory chunk to q. So this node initial address is q, this is our new node. And q arrow info should be what? This num, that is 55. So q arrow info is num. Now I start one for loop. This for loop will execute how many times? For I equals to 1, I less than lock I plus plus. Lock means 2. Means after second location I want to insert our newly created node. So lock is 2. This loop will execute how many times? Less than lock means less than 2 means 1. So this loop will execute only one time. So first time p is 1000. So first time it is p equals to p arrow right. So our new p is this node. Now check if p is null. Is p is null? No, p is not null. It is 2000. So again go to this while loop. For I equals to 1, I less than lock. But see, this loop will true only for one time. So this loop will false. This condition is false. So after this loop, come here. I have to insert this node here. So what is q arrow left? Q arrow left is this p. So q arrow left is p. Q arrow left is p. And what is q arrow right? It is p arrow right. Q arrow right is what? This 3000. From where I can get this 3000? It is p arrow right. So here it is 3000. And p arrow right arrow left equals to q. So p arrow right means what? 3000. That is this node. Arrow left means here. Here you have to give q because I want to insert this node here. And p arrow right equals to q. Here, because I want to insert this node here, here also it is q. In this way, you can insert this node. Another case is, say location number is 9. Means after 9th node, I want to add our new node. But it is not possible because there is only 4 nodes. So I start this for loop for I equals to 1, I less than LOC I plus plus. Less than LOC means less than 9 means 8. This loop will execute 8 times. And when I execute this loop, P equals to P arrow right. First time P 1000, then P 2000, then P 3000, then 4000 and then null. So when P is null, then we can say that there is less than 9 elements. Our next function is reverse a linear doubly linked list. See the discussion first. Reverse a linear doubly linked list. So this is our linear doubly linked list. I want to reverse this linked list. So function name is reverse. I am passing the address of external pointer or header, that is 600. Stock node star p star q. P equal to star ext, Q equal to star ext means P and Q hold address of any node. Here I give P equal to star ext and Q equal to star ext means both P and Q points to the first node. P points to the first node. Also Q points to the first node. Now I want to move Q to the last node. While Q arrow right not equals to null, Q equals to Q arrow right. So is Q arrow right is null? No, it is 2000. So Q equals to Q arrow right. So our new Q is this node. Again check, is Q arrow right is null? No. Then Q equals to Q arrow right. Again check, is Q arrow right is null? No. Then Q equals to Q arrow right. Again check, is Q arrow right is null? Yes, Q arrow right is null. So P points to the first node and Q points to the last node. And this is the situation. Now I start one while loop. While P not equals to Q. Is P equals to Q? No. Then I have to swap between these two info. Take a temporary variable and store the value of P arrow info to the temporary variable. Store the value of Q arrow info to P arrow info and store the value of T to Q arrow info. In this way you have to swap. So after swapping, this is 44 and this is 11. Now P equals to P arrow right. So P equals to P arrow right means our new P is this node. Now check if P equals to Q. Is P is equals to Q? No, P is 2000, Q is 4000. Then this condition is false. Then come here, Q equals to Q arrow left. Q arrow left means Q comes here. Q is this node. Again check while P not equals to Q. P is 2000, Q is 3000. They are not equal. So you have to swap between P arrow info with Q arrow info. Swap between 22 and 33. So here it is 33 and here it is 22. P equals to P arrow right. So P is now this node. Now check if P equals to Q, then break means come out from this while loop. See here P equals to Q, both are 3000, then break. In this way we can get the reverse linear doubly linked list. C program to implement following operations on linear doubly linked list. Our first operation is add a new node after a specified location and second operation is reverse the linear doubly linked list. See the program first. So this is our program. This is node structure. These are required prototypes. This is our main. Initially external pointer is null because no nodes are there. This is one index. I start one do while loop. This is one index. Case 1 is an insert for creation of linked list. Case 2 is add after. Case 3 is display. 4 is reverse. 5 is exit and 6 default. Take the choice from the user. Here I use switch case control statement. Case 1 is end insert. First, take how many number of nodes user want to insert. Say it is n. Start one for loop for I equals to 0, I less than n I plus plus. Take the info part of each node and repeatedly call the insert function by passing the address of xtptr and info of each node. Case 2 is add after function. So first take the position after user want to add. Say it is POS. Then take the info which the user want to add. Say it is NO. Then call the function add after by passing the address of xtptr, the position after which you want to insert and the number user want to insert. Then call the function display for showing the total linked list after add the new node, after addition of the new node. Case 3 is display function. Call the function display by passing the address of extptr. Case 4 is reverse. Call the function reverse by passing the address of extptr. Again call the display function for showing the total linked list after reversal. Case 5 is exit and default case. These are our required function. This is end insert function we already discussed in our previous video. This is display function we already discussed in our previous video. This is reverse function we already discussed. And this is add after function. So I am showing the total program. Node structure, prototype declarations, main, switch case control statement, end insert function, display, reverse, and add after function. So when I run our program, supply your choice. First I create the linked list. So end insert case 1. Supply the number of node you want to insert. Say it is 5. Supply the info part of the first node. Say it is 11. Then second node it is 22. Then third node it is 33. Fourth node 44 and fifth node 55. I want to see our whole linked list. So it is case 3. So this is our linked list. And I want to insert after 33 the node 34. So it is add after. So after 33 means the position is what? Position is 1, 2, 3 after third node. So position is 3 and I want to insert our new node. That node info is 34. So add after 2. Supply the position after which you want to insert 3. Supply the number which you want to insert. Say it is 34. See, after 33 it is 34. Now I want to reverse the total linked list. So it is case 4. So after reversal, I get this linked list and case 5 is exit. This is your programming assignment. Write a C program to implement following operations on linear doubly linked list. First, add a new node after a specified location, and second is reverse the linear doubly linked list. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.